Hi everyone, welcome to my YouTube channel. So today I will be creating a new playlist called Retrieval Augmented Generation. So in this video I will be covering the RAG architecture, so which is one of the most hyped uh, techniques in artificial intelligence. So RAG means that Retrieval Augmented Generation. So let me first clarify what is actually RAG. So I think you guys are know about large language models, which is LLMs. So basically what RAG does is that LLMs are highly capable but encounter several issues like creating inaccurate or irrelevant contents, which is called hallucinations in technical terms, using outdated information, and operating in ways that are not transparent, which is called black box reasoning. And retrieval augmented generation is a technique to solve these problems by augmenting LLM knowledge with additional domain specific data. So let me make it more simpler. I will go this particular architecture. Let's just clarify what actually RAG does. So for example, I think you are aware of GPT and LLMs. So ChatGPT or open source LLMs like Llama 3, Llama 2 models. So these LLMs are specifically trained on particular So these are the LLMs. So whenever they are actually being trained, so certain data are being upserted. So these are the LLMs basically. So whenever they are actually trained, they have some limited amount of data. For example, if I talk about ChatGPT, GPT 3.5, it has, for example, so large language models are trained on a limited amount of data. So if I talk about right now, it's Copa America is happening. So if I ask GPT 3.5, like what is the score for next Argentina versus another football team, but it will not actually get the response because those informations are not being whenever these particular LLMs are trained. So what actually happen is that there are some data limitations in LLMs. So that's why what we are doing is that we ingest our external data sources. So for example, we have a database and we are upserting those data sources into LLMs, and then LLMs gives us the response, something like this. And by these we are actually dealing with our latest data, which is not being trained on LLMs. So that's how actually RAG solves the problem. So here is a basic RAG pipeline. So first of all, the step one is that data indexing. So for example, we have lots of documents, PDF files, Excel sheets, then documents file, everything. So this is our private data, external private data, and those documents we need to index. So what does indexing means? So it's not that like regular indexing like we are using in regular software programming logic, but it's a special terminology. So what indexing does is that, for example, we have lots of documents, then we create a vector database. So I will cover this vector database part in next videos. So let's just get familiar into this architecture, how it actually does. So in the next videos I will covering each of the every components detailed. So we have these documents, so somehow we need to index the data. So for example, just keep in mind that we are just indexing the data in a way that we will store this data into our vector database. Then whenever any particular user will come, they will ask the question. So this question will be searched into this particular vector database. And in terms of vector database, there are different options, like you can use open source vector database or closed source or paid ones. Different vector data storage are available right there. So we will also covering these particular things in detail, like in which case you should use local vector data stores and in which case you should use the paid versions or more scalable vector database. Then we have top k chunks. So whenever you will the user will ask the questions, it will get some similar results out of my vector database, and then it will get top k chunks, and those top k chunks will fed into large language model. And also there are other parameters involved whenever we are generating the response, like top k value, temperature values, and we also tweak that prompt as well. So finally we will get the response. So this basic RAG pipeline includes two steps. First one is that data indexing. So we have to index the data so that we can store the data in a vector store. And the step two is that data retrieval and generation. So whenever user will ask the question, we have to retrieve the data, and we will pass these top k chunks and then pass it to LLM, and then finally LLM will give the response. So that's the basic RAG pipeline in a nutshell. So if I go to the definitions, first of all, LLMs are highly capable but encounter several issues like creating inaccurate or irrelevant content. So why inaccurate? Because of we have limited amount of data that is being any particular LLMs trained on. So that's why inaccurate and irrelevant content, which is called hallucinations. And if I talk about hallucinations in briefly, hallucination means that LLMs will give you the response, but it will be factual response but not accurate. That's what means by hallucinations. And using outdated information. So this is the most important things. Outdated information means these LLMs are particularly trained on limited amount of data. Other than this, it will not get the data whenever you will ask anything. For example, the Copa America. Then, and operating in a ways that are not transparent, which is black box reasoning. So any deep learning architecture, we actually say that it's a black box reasoning. We cannot actually get how it actually reasons the final response. So that's how actually black box reasonings, and retrieval augmented generation is a technique to solve this problem. So it actually solves the hallucination problem, which is inaccurate or irrelevant content, also the outdated information. That's how RAG application works in a specific domain data. So then if I go to the basic RAG pipeline, so first of all, this basic RAG pipeline, we have two parts as I have covered here. Step one is data indexing, and the step two is data retrieval and generation. So here data indexing means that we have the data which is the documents, and we actually split the data. So why we need to split the data? Basically, for example, let's just make it more easier. So for example, you have a PDF file. So this is your PDF file, and in this PDF file you have 100 pages, right? So this is page 1, this is page 2, and this is page 3. If you so for example, for each of the pages there is 100 words, and if I multiply by those 100 pages, which is somewhere around 10 raised to the power 4. So these much of words are right there into my one PDF. So if I talk about we have 100 PDFs, so it will be around 1 million words. But in this case, we will not feed these 1 million words into our vector stores, because like it's like that we are upserting or indexing those 1 million words into one index, but it's not a good option. So that's why what we are doing is that we are actually splitting the data. So and we create text chunks. So for example, in this PDF we have 100 words, right? And if we take for example 50 words as a first 50 words as a one chunk, then second 50 words as a another chunk 2, like this, we can split the data. So in the first page we will have two chunks, because 50 words equals to one chunk and next 50 words equal to two chunks. So we have from the first page we will get two chunks, and like this from the 100 pages we will get 200 chunks. Those 200 chunks from there, so for example this is chunk 1, chunk 2, chunk 3, chunk 4, like this there are 200 chunks, and those chunks will be fed into our vector embeddings. So why vector embeddings we need? What is the usage of vector embeddings? So vector embeddings means that we have the text, right? We have different text right there, but in a nutshell, language models or any kind of models do not understand textual data. So we need to convert this textual data into numbers, specific numbers. So that's why we need vector embeddings. And for creating the vector embedding, so from these text chunks we will create vector embeddings. And why vector embeddings we need? Basically for upsorting the data into vector database, because large language models are not cannot understand textual data. We need to convert into numbers. So I will also cover these vector embeddings. So there are different open source and closed source vector embeddings right there. So if I talk about text embedding ADA002, which is from OpenAI vector embedding model, and also there are open source vector embedding models right there. So if you are familiar with the transformer architecture, so here vector embeddings are actually created, which is a contextual vector embedding. So those vector embeddings are actually converting the textual data into numbers. Then we are storing these numbers and textual data into our vector store, which is called data storing. And where we are storing it is in our vector database. So this is the data indexing part, and the data retrieval and generation part is basically that the user asks the question, and then from the question we create the same vector embedding using the same vector database that using the same model that we have used for indexing. So from the user question we create a vector embedding, then we pass it to vector database to retrieve the similar results, and based on the query it returns top k chunks. So these chunks also stored into our vector database. So those top k chunks are passed into LLMs, and then based on the user query and the top k chunks, LLM give you the final generation. So that's why the data retrieval and the generation comes in. Retrieval means you have to retrieve the top k chunks based on your user query. So in this case there are different metrics are uses for retrieval, which is cosine similarity or dot product. I will also cover these things into the next videos. and finally we will get the response. So after generating the response, which is called the generation part, and whenever we get the data top k chunks from our vector store, which is called data retrieval. And there are two main phases actually, so data indexing, retrieval and generation. So okay, I think now it's being cleared. We will also move into the code part into our next sessions. So till now, stay with us. Thank you.